All right, sports fans, let's get going here with Unit 2. Now, for Unit 2, I'm combining both Chapter 3 and 4 from the textbook. They're basically the same thing. We're going to be looking at triangles. And more importantly, about triangles, we're going to be looking at non-right angle triangles. All right, so that means we're not working with anything. We are not working with anything that has a 90-degree angle in it. So that means you're not going to be able to use SOHCAHTOA. All right, those days are gone. There might be a few questions where you might need that for a secondary thing. Both SOHCAHTOA and Pythagoras are no longer useful here. They're only good for right triangles. So I'm going to erase those because you're not going to need those. Now, here we go. So sine law basically states for any non-right triangle, or even for a right triangle really, this is true. All right? So what that all means is, with triangles in Foundations 20, they always use uppercase letters to represent an angle, and then they use a lowercase letter to represent the opposite side to the angle. So they're always across from another. So big B is this angle here, little b is this side here, and then little c would be over here. So now, with this formula that I've given you here, sine A over A equals sine B over B, sine C equals C, you can solve for anything as long as you have 3 out of 4 things. You're never going to use all 3 of these or all 6 sine or angles and sides together. You're only going to be working with 2 out of 3. So it could be sine A and sine B, or it could be sine B sine C, or it could be sine A and sine C. Something like this. All right, and you're going to need 3 out of the 2 things, or 3 out of the 4 things. Sorry. Okay, and then you'll solve for stuff. Now the easiest way to go through this is just to watch some examples. All right, so I'm going to go through a few of them here, let you guys try some. Most of these are out of the textbook. We'll have to go over how to draw some of the triangles. Sometimes you'll be given a drawing, sometimes you won't be, and we'll go from there. Okay, so for the first one, we're not given anything, we're just given a description. All right, so for example 1, a triangle has angles measuring 80 degrees and 55 degrees. The side opposite the 80-degree angle is 12 meters in length. Determine the length of the side opposite the 55-degree angle. All right? So, I always like to just draw a basic triangle like this. And so I know I have one angle at 80 degrees, and I have another one at 55 degrees. Now, I also know that the side opposite the 80 degrees, so that's this guy here, has a length of 12 meters. Now I want to determine the length of the side opposite the 55-degree angle, x. All right, that's my unknown. So now I'm going to use sine law to do that. Now, sine law states, sine A over equals sine B over B. The letters really don't mean anything. It could be X, Y, Z. It could be elemental P, whatever you want. So for here, all I need to know is that this angle aligns with this opposite side. So I'll start with that. Sine A over A equals sine B over B. I always use A and B just because of the first 2 letters of the alphabet. They're the easiest. So I know that sine 80 over 12 equals sine 55. Now my B value is my unknown, is x. Like so. So now what I'm going to do is I need to get x by itself because that's what I'm solving for. So the first step you always do, so step number 1, I'll write them over here. You're going to cross multiply. Okay? So if I cross multiply, it's going to look like this. So I'm going to get x sine 80 equals 12 times sine 55. Don't forget that little dot there means multiplication. Now I need to get x by itself, so I have x times sine 80. So the opposite of multiplying is to divide, so I divide both sides by sine 80. Like so, so that'll cancel out on this side. So now what I'm left with is, so my second step is to divide. And then the third step is to solve. So now all I'm left with is x equals 12 times sine 55 over sine 80. Okay? Now, to solve this, you have to be careful with the steps. Always work out the numerator first. So for solving, top first. That's your numerator. And then you do the bottom or your denominator. Okay? So I know that 12 times sine 55. So I'm going to punch that into my calculator. Works out to be 9.83. Divided by sine 80. 0.9848. So now I just punch that into my calculator. I go 9.83 divided by 0.9848. And that's going to give me 9.98 meters. And there's my answer. All right, so that's how you do that. Okay? Let's do the next example. Now the next one, this time, once again, we're solving for little c. All right, this guy here. So if I set it up, it's going to be sine 51 over 12 sine 72 over c. So once again, first thing first, cross multiply. So it's c sine 51 equals 12 times sine 72. Then I divide to get c by itself, so it's c equals 12 times. Now, try this one with your calculator. Pause the video if you want. Try doing it all in one step. Go sine 72 times 12, take that answer and divide it by sine 51. Okay, if you get good enough, if you practice at these enough, what you can actually do is you can actually do these all in one step with your calculator, and it can save you a little bit of time to get the right answer. So see if you can get c equals 14.69 meters. Oh, sorry, centimeters. Okay, so if you can do it all in one step, that's great. It saves you some time. Just be careful. A lot of people can set this up and do this part, even get it all the way, do your algebra and get to here, but then they just fumble punching it into your calculator. Okay? All right, let's move on now to example 3. This one is a little bit trickier because now we're getting into direction. Okay? Now, before I start the example, directions are often stated in terms of north and south. Okay? So if you're ever given something like north 30 degrees east or south 45 degrees west, what that looks like is you always measure, never eat shredded wheat. You always measure north up top, south down below. then east is on your right, west is on your left. So now if I said I wanted to go north 30 degrees east, so going northeast looks like this, in that direction, I have to remember that it's north, but then I'm also going 30 degrees from north towards east. All right, or if I was going south 45 degrees west, I would draw my line between south and west, but then my measurement would be here, because it's south, but I headed over 45 degrees to the west. Okay, now let's say I had something like south 60 degrees east, so I started south. I'm going to go off towards the east, and it's going to be 60 degrees. Now these are just sketches. You're never going to have to be perfect with these. You're never going to need to use a protractor to read these angles, okay? Just be aware that you need to know how to do this, because we are going to be doing a lot of this. And look at that, we're going to do it with our next example. All right, the captain of a small boat is delivering supplies to 2 lighthouses, as shown, okay? So his compass indicates that the lighthouse to his left, so lighthouse 1 is over here, lighthouse A, and lighthouse B. All right, so we know that the lighthouses, this is actually on page, what page from the textbook is this? All right, so we know that the boat is down here. Now the information given to us is that we also know the distance from the 2 lighthouses, like so. Oh, let's retry that. Here's B. So the distance between the 2 lighthouses is 12 kilometers. And the distance from the boat to lighthouse A is 9 kilometers. Okay, and we don't know the distance here. Okay? Now, what we want to determine is the angle, the compass direction he must follow when he leaves lighthouse B and heads to A. So the first thing we need to do is we need to kind of solve this triangle a little bit. Now, I know that the boat travels in one direction to get to lighthouse A and travels in an opposite direction to get to lighthouse B. So what I do, whenever you're doing this, you always draw the compass. You know what? I do that. Okay, so let's try this again. Let's draw the compass. All right, so we know the first direction from lighthouse, from the boat to lighthouse A is north 30 degrees west. So if we came off of north, this would be 30 degrees. And then we know the boat travels the second time north 50 degrees east. So we know that this is 50 degrees here from the boat to each lighthouse. So we now know that this total angle is 80 degrees. Now look at that. We have an angle and we have its opposite side. We have a side, and we're looking actually for this angle here because we want to know the course you must chart from B to A. So let's figure part of that equation out. So I know that sine of 80 over 12 equals sine of B over 9. So I'm going to cross multiply, I get everything by itself. Try working on this on your own. It's going to be 9 sine 80 over 12 equals sine of B. So if I work that all out, I'm going to get sine of B equals 0.7386. Then I take all of that here and I put it to sine -1. Once I do that, I'm going to get B equals 47.6 degrees. All right, cool. So now I know that this total angle here is 47.6. But when the boat leaves point B to get to lighthouse A, it's not going to work out like that. Because you have to figure out the course that he's going to travel in directions off of north and south. Okay? All right, there's some angle here that he's going to set north west, right? This is my northwest quadrant. How much is that going to be? I don't know. But what we do know, right? If we look at this here, this line, my horizontal here, it's actually parallel to my horizontal here. So that means, if you look, I'm going to draw this, I'm going to erase it real quick just so you can see it. This line here, I'm going to have alternating interior angles of a parallel line. So I know that this angle and this angle are going to be the same. Okay? So I know that these guys are going to be equal. Just this part of it, just up to the horizontal. Now if I know that this part here is 50, and this total angle has to be 90, 90 minus 50 is 40 degrees. So I know that this here is 40 degrees. So if that's 40, and this total part over here is 47.6, this angle here then would be 7.6 degrees. All right, so that means I'm going to round that just to 8, just so it's easier. So that means he's going to travel from here to there. This is going to be, if this is 8, this has to be 82 degrees. So he travels north 82 degrees west. All right, so let's try to set this one up now. So here's point A. Now it gives you directions. I'll put point A here. So I'm going to draw a compass grid. I know my first one comes off as southwest, 40 degrees. So I know this is 40. To point B. Okay. And then from point B, I also know that it's going to go south 54 degrees east to point C. So if I measure off of south towards east, I know that this is 54 degrees. Now I know the distance from A to C is 12 degrees. So I know that this total distance here is 12 kilometers. So what I want to find now is find the total distance of the boat race. All right, so I need to find this length and this length here. First thing I would start with is I would solve for angle B. All right. Once again, look at that. I know that this is 50, so this here has to be 50. Okay, I'm going to erase some of that just so it doesn't get too complicated. I know that this part here is 50 degrees now. And if I know this is 54, that means this has to be 46. So this total piece here is 96 degrees. So this is what I got so far. I know sine 96 and over 12 is going to work for sine law. Now, what I failed to put down on here, or mention before that we should bring up now, is that from point C, he heads north back to point A. So that means from point C here, he heads straight north. Okay? So that means this line and this line are also parallel. So if those are parallel, I know through my alternating interior angles that this will also be 54, okay? So that's going to be 54 there as well. So you just have to be careful of that. Like if north is straight up and he goes that way, and you have a measurement, you have to watch that. Parallel lines here are going to be key, guys. So that means I can now use this 54 to solve for x over here. And then I know if this is 96 and this is 54, if I minus 180 from 96 and 54, I'm going to be left with 30 degrees here. Now I know that this originally said 40 here, but you have to remember that 40 is off the horizontal, measured off of south. He didn't probably travel perfectly back there. He might have cut that off a little bit. So that's what that's going to look like. So now I have my angles. I can now find my two other sides using sine law quite quickly. So let's start with sine 54 over x. Try this one on your own. I'll write down the answer here so you guys can see it. The first one's 9.8. Now if I want to solve for this guy here, I'll use the same one that I had before, just to make my work a little bit easier. So sine 96 over 12 is going to equal sine 30 over x. Well, this time I can solve for this guy over here. So try this one again, see if you guys can use cosine or sine law on your own. I get 6. So there you go. So your total distance would then be 12. You add up all the sides. He traveled 28 kilometers. Okay? Now, so just remember, whenever you're dealing with sine law, you need either two angles and an opposite side, or you can have two angles and an adjacent side, because if you have two angles, you can solve for the other one quite easily, or you need a side, two sides, and one opposite angle. All right? These are the two things that you really need for sine law to work. All right, and that's it.